In this video we're discussing about a disc brake. So here we're considering Pulsar 150 DTS-i disc brake. Okay, first of all we're designing with three different materials. Okay, these are the three different materials which I chosen. I let you know that why I'm choosing this. Okay, and we use SolidWorks and ANSYS for analysis. At the same time we use the structural analysis and thermal analysis to analyze your object. Okay, first let me know that what is the concept of this disc brake. Before that, this is your aim. Okay, aim is nothing but by using this project you're proving that how much efficient your disc brake. See, if you're using any Pulsar bike in real time, okay, you design your Pulsar bike disc brake as it is like this. See, if I show you this, see, let us assume this is your Pulsar bike disc brake. Okay, and you want to prove, okay, and you want to design a disc brake which is more efficient than this disc brake. To do this, what you are doing, you are creating another disc brake, okay, which is like this. Okay, why I have designed this? Because there is a lot of discussion behind this. I used material structures and weight optimization and heat dissipation rate, different kind of topics I have been gone through, and based on that I came to know one idea which is like this. Okay, and this is the second design and this is the first design which I have created. Okay, see, for this I'll show you this documentation, and in this documentation I am explaining you which one is the best and how you calculate all these things. Okay, see, first of all I have taken the 150 disc brake and I have analyzed it with the help of three different boundary conditions, that is 50 km/h, 80 and 110, with the three different materials. It means for each material you analyzed with 50, 80, 110. It means total 3 materials is nothing but 3 into 3, nothing but 9 cases. For single disc brake you analyze the 9 cases along with another disc brake. It means total 18 cases for structural analysis, and then you calculated the structural and thermal analysis, which is separate 18 cases. That is nothing but total 36 cases you have gone through, and you are telling that which is the best disc brake among them. It's a very lengthy project and very big project, so I'm just giving you one concept so that you can develop it by your own. Okay, and I have created this disc brake based on the dimension, real-time dimensions I have developed like this, and then later I use these materials, and these are the metal properties. Okay, and now I have applied these are the boundary conditions which I have real-time applications. So based on this I got these results. See 1150 rpms and everything I have calculated by my own, because I have mentioned that 50, 80 and 110, right? So based on that I have got these are the calculations, and somewhere I have mentioned might be, okay, it will take some time to check there, but I have calculated like this. See, rpm is nothing but 1850 and 80 kilometers per. How you calculated this, sir? Means you based on this radius and velocities and everything. So we have calculated this rpm. Okay, so now after completing this you got the deformation values, stress and strain and safety factor for each material. Okay, then you increase the rpm and in kilometers per hour. This is how you got. And finally, what you are discussing right now, see, till now you discussed only structural analysis, and now you're discussing about thermal analysis, how the heat dissipation rate is there. Okay, and you have applied this is the thermal boundary conditions, and now calculating the temperature distribution, and this is the heat transfer rate per unit area. Okay, after completing this same cases, and you adjust graphs and everything, and this is how your heat transfer rate increasing while changing the material. Okay, among them this is the highest heat transfer rate it has. And for the structural analysis for the second design, it means till now you have analyzed only for the single design, that is the first design. When you comparing these design results with the second design, and you came to know which is the best. Okay, and the same boundary conditions you applied for the second design also, and finally you conclude that which is the best one. Okay, I'll show you the final results for this. See, in conclusion, there is a very big conclusion in this. This is the, okay, for this advantages of 7068. So if you use the 7068 aluminum metal, what is advantages of that? It is a less in weight compared to the steel and cast iron, high strength to weight ratio, easily available. Disadvantage also is like I need to write right, so that's the reason I'm giving this. Costly material compared to the steel and cast iron, and sim like that. And steel is also, every case, like everything has their own advantages and disadvantages, so I have mentioned each and everything. And finally we are giving that conclusion, like here only we are given, see, approximately 10% of weight reduced because of a cast iron, and the third case we mentioned here. And finally you gave conclusion like, see, to improve the heat transfer rate values, here we modified the disc brake rotor, different holes and groove cut. Hereby observe that cut and holes and values compared to the design, and the aluminum 7068 is the best material among the others. And you mentioned this why it is best, and there's the limitations also you mentioned. Disadvantage is nothing but limitations. Okay, and we are not concluding your project like similar case like there is a open end you are giving that, because one, if you're telling that one project on one material is good, it doesn't mean that the other two materials are bad, isn't it? So that's the reason you're giving that second case also. That means if you're using this second material, whatever the material, like another material like steel or whatever the metals you use, what will be the added advantages or disadvantages of your work? So based on that you're going to decide that which is the best one among them. So this is how you design and analyze your disc brake, and this is a file, okay, analysis file, and I have applied here, these are the boundary conditions, see, okay, and you calculate deformation, stress, strain and everything. And if you have any doubts, like still you have any doubts on this concept, you can message me on this number I have given in the first comment. And okay, I'll let you know that in one single line, by this video you learn which is the best material or which is the best design, okay, and why it is the best design in this project, and how you increase the efficiency of the product in real-time application. Thanks for watching. Thank you.